problem number 2, we now have two functions, x squared minus 1, which is our parabola right here, and y equals the cube root of x, which is our broken curve. And we're interested in the region R, which is in between them. So here's our region R right here. Okay, so for starters, use your graphing calculator to find the left and right bounds of R. Write your answers below. So bring the graphing calculator into play. I got the exact same picture right there, only it's on the screen. We're interested in the bounds to find out where these two functions intersect. Well, they intersect here and there. So we're going to use our intersect command. So that's second trace. Option 5 is intersect. All right, and we need our, it says first curve and second curve, so we're going to just hit enter twice. And then it wants our guess. We're going to guess near that point. So this, where the blue curve, the parabola crosses the x-axis, is -1, and that's obviously 0. So somewhere between -1 and 0. So let's type in -0.5. All right, and we see that our A bound is going to be -0.471. We also need our B bound, so we're going to repeat this process. So second trace, option 5 to intersect, enter on the first curve, enter on the second curve. This time we're looking for our point to the right, which happens sometime after 1, so let's type in 1.5. And in fact, it's 1.46107. All right, so those are our two bounds. Part A is done. Part B says write, but do not evaluate an integral expression for the area of R. Okay, so we just want the area. So we're looking at the integral, no pi, no squaring. We already have identified A and B right here. So we have integral from A to B, which are those bounds. The top function is our cube root of x, so that goes first. Our bottom function is x squared minus 1. We need to make sure that we have those in parentheses, and the whole thing is dx. All right, and we are done. Okay, now part C. Write but do not evaluate an integral expression for the volume of the solid generated when R is rotated about the x-axis. Okay, so we're having the same order here. It's just that everything's going to be squared. All right, with pi out front. So pi times the integral from A to B, cube root of x wrapped and squared, minus x squared minus 1 wrapped and squared, and the whole thing goes to the dx power, or rather with dx differential at the end. Part D, write but do not evaluate an integral expression for the volume of the solid when R is rotated about the horizontal line y equals -2. Okay, back to our picture. Y equals -2 is the region below the curve, so therefore we are going to subtract -2 or add 2 to both parts. So volume is pi times the integral from A to B of cube root of x plus 2, which is not under the radical, wrapped and squared, minus x squared minus 1, but then we're going to add 2. So x squared minus 1 plus 2, that's also wrapped and squared, and the whole thing receives dx. All right, and finally, we're going to go around the line y equals 3, which is above our zone. So volume, just like on the previous problem, we have pi, the integral from A to B. We will have 3 written first. We're not going to use cube root of x first because that is now further away from the line y equals 3, so x squared minus 1 is going first. So 3 minus the quantity x squared minus 1, and that is all going to be squared minus 3 minus the cube root of x wrapped and squared, and then we need a dx for the whole thing.